In this video, we're going to quickly look at some organic reactions that apply to alcohols. So the first reaction is addition reactions. It's possible to do an addition reaction to produce an alcohol, but what you're going to use is a water molecule, and the water molecule is going to act like an HOH. So at one carbon, you're going to get a hydrogen, and at the other carbon, you're going to get a hydroxyl. So if we had, say, propene, CH2CH3, I'm going to be able to add, we're going to react it with water, and you're going to get an H on one side and an OH on the other side. And again, because this is a nonpolar molecule, HOH, you could also get the OH bonding here and H here. So we're going to get more products. So I might get CH3, CHOH, CH3, and I could also get CH2OH, CH2, CH3. And so this would be propan 2-all, and this would be propan 1-all. And so just kind of like when we were doing an addition with a hydrogen or an alkyl halide, so like hydrogen bromide or hydrogen chloride, where you get this asymmetrical molecule being added on, we have the same thing happening when we make alcohols using water and addition reactions. Another kind of reaction that occurs that's a new one is an elimination reaction. So elimination reactions will look almost exactly the opposite to the addition reaction. And so elimination reactions typically are going to, will always make a double bond. So here we've got an alcohol, that hydroxyl and this hydrogen, in the presence of an acid catalyst, the hydrogen and the hydroxyl will make a water, and we get a double bond built between the adjacent carbons. And so we've got the elimination of some parts of the molecule to make a double bond. Elimination reactions typically are going to happen with alcohols or alkyl halides. So if I have an alkyl halide, I can remove the chlorine here and a hydrogen from an adjacent carbon to form a double bond. But in this case, there needs to be a strong base. And so that strong base, we've got the K plus and the OH minus. The OH minus will bond to the hydrogen to make this water. And you're going to get the chloride will bond to the potassium to make potassium chloride. And you're left with the double bond between those adjacent carbons. And so obviously, again, this is another case where you might have isomers forming. So if I had CH3, CH2, CH3, and if this was let's say a bromine, and I put it in the presence of a strong base, so we'll just say it's an OH minus. Maybe it was NaOH or something like that. The OH is going to bond to a hydrogen. So that hydrogen could come from here, and it would make a water, right? We're going to get a water produced from that, from taking this hydrogen that's over here, and that bromide is going to come off. It would be attached to this sodium if we wrote it down, but if you've just written OH minus, it'll just be the bromide. And then what we're going to do is we're going to get a double bond occurring in here. So I'll get CH2 double bond CH, CH2, CH3. That would be one of the reactions that's possible. So this is going to make a prop-1-ene from a, but-1-ene from a 2-bromobutane. So this hydroxyl, though, could react with a hydrogen that's over here too, right? Because it's just got to be an adjacent hydrogen. So if that reacts to make that second water, I'm also potentially could get CH3, CH, double bond CH, CH3, and I'll get two bromides, two waters, and I get the two different isomers. So I have this one, which is the but 1-ene, and this is but 2-ene. And those are two possible isomers that can form. So an elimination reaction will happen with an alcohol or with an alkyl halide. If it's an alcohol, they usually have an acid catalyst. If it's an alkyl halide, they'll have a hydroxyl. And you should be able to predict what the products are as well as their names. There are several questions for practice in here related to these topics. Please make sure you complete those questions.